Real-time location systems have been considered rare and exotic technology deployments until very recently. RTLS has been used by luxury car companies like BMW to track the location of 3 Series and 5 Series models mixed on a single high-tech production line, but these systems cost millions. Now, Bluetooth is changing all of that in a way that's sparking a wave of innovation, not just in high-tech, but in warehouses, manufacturing facilities, hospitals, and office buildings around the world. Speak to the CEO of any Bluetooth beacon vendor, and 9 out of 10 of them will tell you they're focusing on the enterprise where the ROIs are specific and measurable. RTLS is a key application for that. Last week, I had a fascinating discussion with the guy that literally wrote the book on RTLS, Ajay Malik. Ajay is one of the most joyful technology geniuses in the business, and he's been working in this space for years. So it was wonderful to have him explain it to us firsthand. Check out this important episode and do subscribe on mrbeacon.com, Facebook, YouTube, or your favorite audio podcast platform. Ajay Malik, author of RTLS for Dummies, thanks so much for joining us on the podcast. It's a real privilege to have the person that literally wrote the book on RTLS. Personally, I have 2 copies of your book, the Kindle and the paperback. So it's incredibly thorough, and it's definitely not for dummies. It's comprehensive. It goes into quite a lot of detail, but it is super accessible. So enough of the flattery and praise. Tell us, what is an RTLS?
So RTLS stands for real-time locating solutions.
Uh-huh.
And the way you see GPS, outdoor location, right? Everybody knows GPS. You can find where you are, or you can find the nearest pizza or anything.
Mm-hmm.
So RTLS is everything about real-time locating, and that could be indoors or outdoors. It could be knowing your position or knowing position of something or somebody else. So the book is all about all technologies, all ideas about various solutions, the challenges you face in doing RTLS. And
that's very good. Yeah, that makes sense. And but let's just go one stage deeper. What do you see as the boundaries between an RTLS? When is an RTLS not an RTLS? Because there's a lot of systems that are dealing with presence and location. Where do you draw the boundaries? And I think you went pretty broad in your book, but if you're being very kind of precise, what would you say the boundaries are of an RTLS?
Wow. You know what? My boundary, I do not have a boundary. My boundary is if there is a location, and I call it granularity. And so to me, I am on Earth, that's real-time locating. or the rover is in Mars, that's
Okay.
real-time locating.
Yes.
As well as I am in America, or I am in my home, they are all location, or it could be, I am 37.456, I can give you the full GPS coordinates. It could be at that level. So I go like very precise to very broad, and that's how I define granularity.
Okay, so we're talking GPS, and we're talking Bluetooth tags, and we're talking ultra wideband, and what have I missed off that list? What do you think is in the RTLS bucket?
Very good. Lot of technologies. So let's talk about the technologies in the outdoor space, right? So you have GPS, you have the cellular based location, like which cell tower you are connected.
Mm-hmm.
You have the location based on which satellite you are connected. You have outdoor location based on just physical visual presence, like a camera snapshot or the satellite imagery telling who is where, things like that. Then when you go in indoors, there is a plethora of technologies. You have Wi-Fi, Bluetooth, Zigbee, a lot of technologies. There is a lot of RF space which is open. So like you will have in 400, 33, 800, 900, 1800, 1900, all megahertz space, lot of technologies in that space. You have technologies which are locating based on sound, right? Or ultrasound. You have technologies like ultra wideband. You have technologies on you can locate based on ultra low frequencies also, right? Like I was recently reading, and that was pretty one of my another new area of interest I am exploring. Like our brain waves, they also have a pattern, and they are actually ultra low frequency waves, and they can be also transmitted and recognized. So in fact, there are some defense projects where they are actually putting some big, large sensors. So this is how they detect human presence. It's amazing. So the technology range is very broad also.
That is tremendous. And how did you get into this space? And why did you write this book?
Oh, all right. So I tell you, right, this is started in around, not for the book. I was with Symbol Technologies. Symbol, I don't know if you have heard of it. They make the barcode. So Symbol owns the patent on the barcode. They invented the barcode. Okay, and they were doing Wi-Fi. We were designing Wi-Fi, and we were like part of Wi-Fi Alliance, defining 11B, 802.11g, and all those space. Then Symbol bought a company called Matrix. It was an RFID company, and my manager said, Ajay, I want you to figure out how you can integrate RFID into Wi-Fi. And I started looking at RFID, and then I was like, wow, I can get the RFID tags reading at each reader level. But like, what, I was coming from the Wi-Fi background. So for me, it was very natural to see that I can manage multiple RFID readers from the same same central controller. I can manage multiple readers. Okay. And then pretty soon my idea became that I can allocate tags. I can locate tags, and I can locate tags across the building. And it was like, wow, it's not just I can locate a tag or read a tag, I can tell the location of tag in the building, a holistic view, right? Where the RFID tag has been. And then it was like, oh, we can do the same for Wi-Fi. And then I started talking to more companies, and there were a lot of companies in ultra wideband space, on ultrasound space, Bluetooth space. Those days it was not called BLE, and it was like I was learning on steroids. And I was talking, and since I was part of Symbol, and then Symbol got acquired by Motorola. Motorola being a big company, a lot of small companies wanted to interact. So I was just lucky to be at the center of all the location activities happening. And I was learning so much. Why I wrote the book, so that's a different story. My wife always wanted me to do masters. I have not done masters, and she was like, you should study more, learn, you cannot just do bachelors, you have to do more. And so I said, the dummies people at that time, one guy had contacted me that, would you be interested in doing a book? So then I talked to my wife and said, if I do a book, then does that qualify as master's or PhD? And she says, yeah. And I said, okay, I'll do it. And then and the dummies people, the Wiley brothers, right? Wiley company, they do a pretty good job. They assigned a big team.
Yes.
And they do a tremendous job. It was, especially I'm not a non-native English speaker. And they worked with me. They had like a team of 15 people, editors, readers, proofreaders, and to help me. And I'm writing and drawing things, and they are like helping me. And
you have cartoons as well. It's like the full production, entertainment, information, everything you should want. And,
they did. And to me, like the name of the book was Dummies. I think it is just like this, but it was like to me, it was like a reference building. I was putting a lot of stuff, and it was very good exercise. And that's why, like, I wrote the book for that reason. But when I was doing it, I tell you, I learned so much. It was like doing a PhD. Because
I felt the same way when I did the Beacon Technologies book. And really, I loved it so much, I carried on doing these interviews to kind of keep that experience of learning.
Very nice, very nice.
So that's wonderful, and once again, RTLS for dummies. Why would we want an RTLS? What are the business drivers that are actually causing people to implement these systems?
Lot of business drivers, and in fact, the word RTLS, like when it started and where we are today, the word RTLS as a word or phrase may not be as known, but what the word people know today is IoT, or virtual reality, or augmented reality, or machine learning, artificial intelligence, right? And I think those are the applications which have developed around this whole world of RTLS. And in fact, even at the time when we were doing RTLS, and I'm sure you were dealing with it at the same time, these used to be called machine-to-machine things. We did not have the term IoT, but we were using M2M, MDM, different terms. People were talking about these things, and they are the same things. We have been using them, and people were talking the business cases. All those business cases are still around. Many more, right? So why will people do RTLS? So, same reasons which you do anything, right? Top reasons are always, I qualify generally reasons for anything in buckets of, I want to make more money, I want to save money, I want efficiency, I want entertainment. And these are the 4 reasons I want to do things. And RTLS gives you business drivers in each case, and every vertical has different use case. For example, like you have a use case of proximity marketing, that hey, when I see somebody, I want to send you a coupon. Or if you came again to my shop, hey, or you are a frequent visitor to the shop, I want to give you something more, right? And I want to keep coming here. So I need the location. So the location becomes like a revenue driver, marketing driver. The location also becomes, I want to find all my assets for tracking. In healthcare, they say people spend about 13 minutes, nurses spend about 13 minutes every hour for finding things. So that's a lot of time being spent. And so you want that. So you want to put tags or either put tags or the devices are coming up with some integrated approach so that they can be located. And a system so that nurse can find it easy, right? Or you want to find the doctor where the doctor is, right? And you want to find the nurse. So you have reasons like that. Or in like Amazon warehouse, you want to locate things when the robots are actually picking up things and getting things. You know what? The only way, and they do not put all the things in order.
Right.
They put things like that. In that case, you need robots to find things. And the only thing they can find is by using location. So that where the location is. So location becomes a part of the business, right? Location also becomes part of your efficiency, find the fastest route, right? If I am driving, and you know what, when we have autonomous cars, right? Or autonomous forklifts, right? When there is no human involved behind it, or human driving it, the only way they will approach things or they will do things is by making use of location. Location has been always fundamental for everything, right? I think there are 2 things which matter and for which we do not have our own internal sense, location and time. We need those 2 things from outside. Everything else, human being has everything inside it.
So you've cited a lot of different applications there and reasons why people would implement an RTLS. Obviously, there's a cost involved, and some of these systems can be very expensive, although the price seems to be really coming down. We'll talk about that later. What do you think are the most potent drivers of an ROI? Where do you see the sweet spot that is driving investment in this? Because my sense is that RTLS has been around for a while. Your book, how old's your book now?
It came in 2009,
and I read it, and it was like it had been written yesterday. And it was kind of uncanny. It's like I feel like this stuff just came out. I can't believe the date on this book. So in some ways, things haven't changed, but I do feel like there's a lot of changes. And again, we'll talk about what changes have come since you wrote the book. But let's get back to the center of this question, which is, where do you see the biggest drivers for actually people implementing projects? And if I'm building an RTLS company, if I'm building the software or the hardware, what are the applications that you think are going to be the most successful in this space, and why?
Okay, so there is one application which is around asset tracking.
Yes.
It will always be there.
Yeah.
And people will need it, and I think that is like now a baseline application, and it will be always successful.
Yeah.
Okay, people need it, and people need to find things, whether it's home, commercial, enterprise, a big factory, wherever it is, people need it.
Yeah.
I think that is one space. I think a modern driver for RTLS will be around contextual computing.
Mm-hmm.
Okay, so what I mean by that is, like when you are doing machine learning, you want to know where you are learning that data from. And you need to look at that data. So the location is very fundamental, another fundamental element for machine learning. And that's where all the modern applications around artificial intelligence for improving efficiency, or robotic applications, all the applications for virtual reality or augmented reality, they will use location as a very fundamental application. And I think that is where the RTLS will become much and much important. And because RTLS will not be used by humans directly. Mm-hmm. And when its technology has to be used or operated by non-humans, and when I say non-humans, I mean robots or softwares or machines or things like that, that's where it becomes very, very critical. RTLS will play a very critical role.
Yeah.
Am I making sense in this space?
Yeah, absolutely. Yeah. I mean, my sense is that you've described some technologies in the book like ultra wideband. I think that's a really interesting area, because it, to me, was one of these technologies that really established that you could have very accurate location for assets, but in its original instantiation, it was pretty expensive. RTLS systems would cost a lot. And so you saw them being used by the luxury car manufacturers and so forth, BMW, and for finding tools and locating the things on the production line. But my sense is that, Bluetooth, and obviously I'm a Bluetooth guy, but I'm super interested in all the other technologies as well. But that has really, it's kind of bringing the price down, and so you have ultra wideband coming down in price as well. So I think my belief is that we're actually going through kind of a renaissance, a kind of a second wave where suddenly, and of course the Bluetooth standard's about to change, and it's going to embrace location and asset tracking and so forth specifically. And so I think the price is going to come down, and they'll be used more often. But it's not that this thing is new, which is great. I think for anyone that's developing a business in this, then people have been doing this for a while. A lot of the software has got the slots in it. So let's go back and have you talk us through the different technologies that can be used to locate. And I think that's a pretty broad question. So there's kind of different spectrum and radio technologies, and then there's different techniques. So maybe we should start off with the techniques. And first of all, you talk about trilateration and triangulation as a way of locating things, and I think most people kind of have a vague understanding of what that is. But what's the difference? What's the difference between trilateration and triangulation?
Okay, and you know what? Most people use triangulation when they actually mean trilateration. Okay. Trilateration is a tongue twister, and it's a complex word, right? So people, whenever you are computing a distance between more than 3 points, so you are trying to compute distance from 3 points or more points, like a polygon, that's where what you say, I'm using trilateration. When you are using distance from all the points and you are computing the center.
Right.
Based on the distance from all the points.
So this is basically you're drawing circles, right?
Yes, basically you are drawing circles. Yes, like you take, if you have 3 points, you draw a circle on each point.
Yeah.
Okay, and the distance as the radius.
Yeah.
And then where these 3 circles intersect, that central point is your trilateration result.
So that's trilateration, and that would typically be used by standard Bluetooth beacons where you're
Yes.
measuring signal strength, right?
Yes. They translate, what they do is they will take signal strength, and there is a formula, and they will convert signal strength to distance, and now you have the trilateration.
Okay, so yeah, so you've got a warm signal here, a hot signal here, and a cold signal here, and so you infer distance, and then you draw those circles, and you have a rough idea where something is. Well, if that is trilateration, what on earth is triangulation?
Yes, people, that's triangulation is actually very complex, and triangulation is actually using the angles. So it's actually you are determining that what is my angle when the signal is coming. You can actually, you not only know the distance, you also know the angle, and so you can actually compute very nice, because now you know in the 3D space how the distance is. Like in trilateration, let me give you an example. When you have 3 beacons, okay, so what you compute is, you say I have 3 beacons in the on the ceiling. So center of the location is actually somewhere in middle of the ceiling, but extrapolate it in the third dimension to say you are on the floor, not on the ceiling.
Right.
And that's what you do. But in triangulation, actually when you are on the floor, you not only know the distance to the beacon, you also know the angle of the straight line that goes between you and the beacon.
So you potentially you have like X, Y, and Z.
You X, Y, and Z, and that's what the triangulation is. But you know, most of the technologies do not give you Z or angle. Like in RF, most of the times it's omni. You know, all RF is coming, you do not even know the shortest path, and the shortest path may be coming through reflections or refractions.
Yes.
So you do not know that path. So you actually always end up doing trilateration.
Right.
But you call it triangulation. Everybody calls it triangulation.
Yeah.
I think it's just easy to say, and that's how, you know what, people figured out, I'm triangulating it.
Yeah.
They have created a word around it, verb around it. Mathematically, it's different.
Yeah, absolutely. So, and I think that there are a few vendors that are doing that. One of my favorites is Cooper, and I think this is a Finnish company, and they have like multi-segment antennas, and so they literally do measure the phase of the signal crossing the antennas, and they get the angle, and so they're pretty accurate. But you can get accuracy with trilateration, I guess. But what are the different techniques? At the center of this is knowing how far away the asset is, the thing that's being tracked, from the thing that's locating it. And can you just kind of run through quickly some of the ways of doing that? Because there are many, aren't there?
There are many. And you know, let's talk about the RF technologies. All RF based technologies are, there is some kind of RF wave, some like 400 megahertz wave or 2.4 gig or 5 gig, some wave is coming. And when the wave is coming, what happens is, when the wave comes in the air, right, the higher the frequency, right, like 2.4 gig versus 900, which is the higher goes less distance. What that means is the wave attenuates, the RF power attenuates. Like as a receiver, you cannot even see it if you are too far. Okay, so I cannot see something too far, and things deteriorate exponentially. What that means is the graph looks like almost like this. So when you are close, the RSSI is pretty good, but the moment you are becoming far, the RSSI now goes like this. So you cannot tell I am 30 meter or 50 meter, RSSI is same. So this is where all the technologies, the distance from the source of RF and between the receiver of the RF has to be not too far. If you are too far, it's very hard to compute the location. And
yes,
this is the crux of all technologies, and they are trying to solve this problem. In fact, let me just add one thing. You know, what is the biggest challenge in the location world, and why beacon is good, and you know, and how they solve exactly this problem? Because the problem was, how do I add a large number of location sensors or transmitters or receivers throughout the building?
Yes.
And it was a real problem.
Yes.
And everybody is trying to solve it. Ultra wideband, ultrasound companies, Wi-Fi companies, even Bluetooth companies were coming up with solutions.
Yeah.
And then they were coming up with a whole bunch of proprietary solutions or standard-based solution. But the idea was you put all of them, and installation of all this is very difficult.
Yes.
It's actually very difficult. And I think the number one challenge is this, that the installation of establishing the background infrastructure to locate is a lot of work. And this is what I really liked about the beacon or iBeacon, right? When the Apple did it, that was like, whoa, very smart.
Yeah.
They said, made it a standard so that everybody can use it. And now I can start putting these iBeacons wherever I want, in the ceilings, or hide them here, there, wherever, and put them everywhere.
Yes.
And the technology was low energy, so you could run them for 2 years, 3 years, 5 years, figuring it out how you want to do it.
Yes.
And it is manageable solution. So they created they solved the infrastructure problem. And how it solved is, if the beacons are everywhere, now you do not have the distance problem. And
right.
Now you are close to the beacons. And since you are close to the beacons, you will start getting location accuracy, because you are in this part of the curve of RSSI to distance, where RSSI is quite, you can use a formula easily. But when it goes at that range, it has no meaning. So this is the main thing behind all these technologies. And I believe beacon has been a smart thing.
Yeah, very good. Well, and just to recap, so you started off talking about some of the challenges with RSSI receive signal strength, and the fact that because there's this logarithmic curve, when you're far from a beacon, it really is impossible to tell, with any precision how much you've moved. If you're like 40 meters away from a beacon and you move 5 meters, it's very, very difficult to differentiate that accurately. And so I think one approach to this is angle of arrival, but that has all its some challenges in terms of having to have lasers and precisely set it up. And what I think you were saying is we've had this beacon revolution where for anywhere from $5 to $50, let's say $20 or $30, you can get a very good Bluetooth beacon. You can put a bunch of them everywhere, even up and down escalators when you're going between different levels, and then you can track location a lot more easily. And I saw that. I was at the HP conference, Aruba, and they had their beacons, and they mapped this huge hotel basically in a weekend. Stuck a bunch of beacons everywhere, and they had a really nice conference map where you could find your way around. So that's some of the benefits of that. So we've got kind of the pros and cons of RSS and the classic beacon. We've talked about angle of arrival, but there's more, isn't there? There's all these time. Talk to me about the time-based techniques, because this is the thing that really confuses me. So round trip time of arrival. Try and make that simple if you can.
So you know what? Let me tell you, right? Like I have in the book, I put the techniques in 2 categories.
Yeah.
Okay. One is like I call ranging techniques, like how do you guess the distance, and then second is the position estimation. Like once I know the range, how do I compute it? Okay, and let me go into both of them. So in ranging, one of the simplest technique is proximity. And iBeacon does that very well too, right? Are you nearby? That's it, good enough. If I see you, I know you are near me. Like when I'm with my kids and walking, and I'm like, if you can't see me, I can't see you. Stay nearby, and that is the model. As long as we can determine. Then you have something called time of arrival. Okay, time of arrival is if I can determine the distance, time it takes for signal to start from wherever you are, whoever is transmitting, whether it's the IM or as an asset or my tag, or it's the location sensor or location transmitter, whichever is transmitting, if we can determine the time from where they start to the time where I am, and this is actually a very important technology used even in GPS. They put a timestamp, like what time the signal, when it is coming down, what time it started from the satellite. And since I know the location of satellite and I know the distance, since the distance is a lot, the time distance gap is meaningful. Right?
But these things, if you're in a warehouse, that's a pretty small distance. And presumably these signals are going, the speed of light or close to it. So how can you use timing in that close proximity?
So this is where the ultra wideband technologies and some other companies, what they started doing is they put actually a lot more gear. infrastructure background gear to time sync at a nanosecond level or microsecond level between all the location receivers or sense transmitters.
Yeah.
It's a lot of work to put all those cables and keep them in a time sync at that level. Because if you are pretty time synced and you have the real time clocks capable of doing it in nanoseconds, then it's not that bad. Because I can compute the distance, even the 5 meter means something in nanoseconds, right? But the moment you go, you know what, that technology, that circuitry is expensive, and installing all that background wiring and time sync capability is expensive and a lot of work. And it's a lot of cables and a lot of things. And the moment you do a time sync on a low, like I know in milliseconds, hey, everything is okay, like a signal which goes from where I am and across the earth, right? If just it goes, it will take, I think it's over 100 milliseconds to go across. So it takes time. So, but it's 100 milliseconds for across the earth. So between the warehouse, it's nothing. It's not a 1 millisecond. It's actually in microseconds. And that is why if you don't have those technologies, time of arrival is not really effective. Until you are willing to install all that gear and use technology based on that. Okay. Then you have time difference of arrival. Okay. So what time difference of arrival is little difference from time of arrival. Again, you need a lot of precision. Okay. So all these time arrival technologies, I think to make them work in warehouse, a lot of hard work. I think these technologies make a lot of sense, like you really cared about location at a very high accuracy and you are willing. So you can deploy things in a surgical center, operation theater, a small dedicated space where I have a focused niche application and I need this. Otherwise, it's way too much deployment for people. Right. And in time difference of arrival, what you are doing is they all are synced up. And now I know this time it took from this signal versus this. So since this is the difference, based on that difference in microseconds, I compute the range, how far you are versus this.
Very good. And we could spend more time talking about it, but if people want to know more, because there is more and you know more, they just need to buy the book and read that. So just a couple of things, then we're going to have to round up. So very quickly, I was really interested that you covered security in your book, and you talk about that. And I have to confess, I haven't really thought that security was that important with kind of an asset tracking system. But tell me different. What should we be aware of in terms of security with RTLS?
Okay, so security, for anything and everything, there are two aspects of security: privacy and security. Okay, and there are people out there, whose job is this. I was reading that the cyber hacking industry, it's a $120 billion industry. That's a lot of money. Like that's a lot more money and a lot more accessible markets than a lot of people are doing their business in. So it's a very lucrative business. If you want to do bad stuff, there is money for it.
Okay, so this is the size of the market. If I'm a black hat, if I'm a bad guy, there's money to be made, unfortunately. Okay.
There's money to be made, unfortunately. It is so sad, right? But that's how the world works, right? So there are people who will, so let's talk about beacons, right? So people can disrupt. So there are people who want to just disrupt the workflows because just to mess you up, or they sometimes do unintentionally, right? And like, for example, in iBeacon world, let me give you an example in iBeacon world. iBeacons are spread out in the building. I figured out what iBeacons are used. I figured out the beacons which are used for gate 76 in an airport and gate 73 and everywhere else, right? And if I had some malintention, I can put bad beacons, same beacons, and put at somewhere else, so that when the police or some real security people wanted to use those beacons for their location to catch, they are confused and they will go in the wrong direction. It's like giving the wrong directions to people.
Yes.
You see what my point is?
Yes.
We have to protect our beacons. We have to protect that nobody can just rogue beacons, can put rogue beacons. That is one case, right? The second thing is somebody can go and reconfigure a beacon intentionally to give a wrong direction if it was for a wrong direction, or it can change the asset ID. And you may think the asset is still in the building, but when the asset is not in the building and somebody may be stealing, like in healthcare and all, a lot of things people are putting asset tags. They are actually, they're very expensive things, like $75,000, $100,000, like the scopes they put through mouth and all those things. They're expensive gadgets and they're putting tags on them. And if people can just put fake tags on them or fake tag on something else and then take it away, the system will not know. So you need to protect the IDs.
Yes.
And it has to be encrypted sufficiently so that it has to be non-changeable sufficiently, and you have to have ability to detect there is rogue or misplaced or somebody has done tamper with that asset. So that is all critical. That's why these are the top reasons I believe one needs to make sure there is a system in place for protecting the beacons.
Yeah, very good. Well, this has been wonderful, Ajay. Thank you so much. We've covered a lot. We've covered, why and what and how. But there's more in your book. I know you've got some great guidance for people that are looking to buy and implement systems. So people should check out RTLS for Dummies by Ajay Malik. And Ajay, thanks so much for spending time with us.
Oh, thank you, Steve, so much. This was my pleasure. Thank you.
So, are you a musical person?
Musical? Yes. What does that mean, though?
Well, do you play music?
I don't play anything.
What about listening? Do you an avid listener?
I listen to everything. So, but I'm a more I would say more recent than old songs kind of guy.
All right. Very good. I admire that keeping on top of things. I'm stuck in the 80s myself. So the classic Mr. Beacon question is what 3 songs would you take if you were going to Mars?
I know. You know what? When I'm going to Mars, that will be Indian music.
Very good.
Those will be Indian songs.
Well, excellent. Which 3 would you choose?
Which 3?
Yeah.
I think I will pick one song. This is from a movie, a 20-year-old movie actually. It's called DDLJ. It's a full form. It's an abbreviation, and I'll pick one song from that movie. I will pick one song from. There is another movie. I'm giving them because they are Hindi names, and that movie is called Dil To Pagal Hai. It means like the heart is crazy. And I pick one song from there. And I pick one song from a movie. It's called Ankush, Control. And I'll pick, this is more like a prayer song.
All right. Very good.
I'm a religious person also.
Okay. Sure. Tremendous. That's great. This is a first. So we actually haven't had. People normally choose Western songs, and I'm so glad that you've gone against the grain and you're giving us a little bit of a broader audio landscape. So thank you for that.